Greetings. In this video, we want to look at the salt of a strong acid and a weak base. A strong acid produces a conjugate base A- that does not interact with water. A weak base produces a conjugate acid BH+ that will react with water. And realize that a salt has a cation and an anion. So if I have, and what we want to do now is look at the relationship between Kb of a weak base and Ka', its conjugate acid, okay? And what happens is that BH+ reacts with H2O to form B plus H3O+. So if I had a salt where this was strong, it only goes in this direction, but this was weak, then this does not go this way, but this does go this way, and it forms some of the base. Okay? So what do we know? We know that we have a table of KBs, and incidentally, we can get these from the back of the book, or in our case, LibreText. And here we have a bunch of KBs in the LibreText table 16.3.2. And these are the different values of KBs. We notice that all of these have got nitrogen with a lone pair of electrons. And what we're going to learn is how to get the Ka of its conjugate. Okay? So Kb is equal to BH+ times the hydroxide concentration all over the initial base concentration. Now, its conjugate, BH+, so this could be ammonia, ammonium, okay? Here I have the Ka', because this is the conjugate acid of this base, is equal to the base concentration times the hydronium all over the BH+. And in both of these cases, we omit the water because its concentration is so great that it doesn't effectively change. And what we notice is that Kw is equal to Kb, Ka', and let me repeat, many books don't use a prime here. I'm only using it to indicate that this is a conjugate, okay? So we have tables of Ka's of acid, tables of Kb's of weak bases. We can also calculate the conjugates, that is the salts of those weak acids or those weak bases, using this relationship. So I now have Kb times Ka' is equal to BH+ times the hydroxide concentration over the base, okay? That's my Kb, which I can get from the table. Now I have my Ka', and here I have the base concentration times the hydronium all over its conjugate acid. And this is equal to the base over the base cancels, the conjugate acid over the conjugate acid cancels, and I get OH minus times H3O+, which equals Kw, which equals 10 to the minus 14. So this is important. I could have in my table of weak acids a Kb. I now can, so if I had ammonia, I could calculate the Ka' of ammonium. That is, Ka' is equal to 10 to the minus 14 over Kb. Okay? So getting back to our table here, this table is really two tables. It's a table of Kb's as written, but every one of those bases has a conjugate acid. And if I added that acid to a salt, it would be acetic, okay? And so I can calculate these. And so, for example, here I have ammonium chloride. Ammonium chloride is the salt of HCl and ammonia. HCl is a strong acid, so chloride does not react with water to form HCl. But the ammonium does, okay? and the ammonium protonates the water, forming ammonia, okay? The ammonium protonates the water, forming ammonia, and in the process forms hydronium, and therefore the pH is less than 7. And I can calculate the Ka prime of ammonium knowing the Kb of ammonium, okay? Hope this all makes sense. It's a bit of a tongue twister.